Hello everyone, and welcome back to another geostatistics lecture video. And in this video, I want to walk through a specific example of a kernel density estimator, walk through the equation, and then start the building block of going through a calculated small-scale example. So if you're going to implement a KDE in R or in GIS, most likely what will happen is you will end up with this default kernel, which is called the Quartic. The Quartic kernel. So this is the actual equation that is going on under the hood in most of the R packages and in the kernel density estimator in ArcGIS Pro. So let's take a look at what this equation looks like and explain the parts and where they come from and how they're related to what we're actually calculating. So again, we're looking at density, because that's the whole point of kernel density estimator, is to calculate the density. Right, and this is going to be equal to 1 over r squared. Right, and we're going to multiply this by the summation from 1 to n and then inside of this, this is where things get a little bit tricky. Right, we're going to multiply 3 over pi, which is a constant, times a weight, which we'll talk about the weight in a second, and then 1 minus the distance sub I over the radius again. We're going to square that result, subtract it from 1, and then square that result again. And that is going to be what we're going to sum. So let's take a look at this equation. Okay, right, this 3 over pi, this is a constant. We're summing, right, this weight. This lets you control, I shouldn't say control, this lets you add in a variable. Right, this essentially turns this kernel density estimator into into sort of a version of interpolation, but for now, right, we're going to assume equals 1. Right, we're not going to worry about this w parameter in the case of the kernel density estimate that we're talking about. This w is essentially going to be 1. But what you can do in ArcGIS Pro and some other examples is you can actually throw a variable in there, and that's going to let you alter this so that you're basically doing a form of interpolation. Right, so this 3 pi is constant. Right, this dist sub I, right, this is that distance that we talked about last time. Right, this is that Euclidean distance. Okay, and then the r here, this r, this is that radius, or you'll often see it referred to as the bandwidth. Okay. So again, these are the same things that we talked about. Conceptually, right, what the kernel is going to require, it's going to require some bandwidth that you choose, and it's going to calculate the distance between each point in the data set and the sort of unknown point that you're dealing with. And it's going to sum up all of those distances, multiply it by 1 over the radius squared, and that's going to give you your density at that point. And then you're going to repeat this process. For example, if you're creating a raster output, it's going to repeat this process to calculate the density for every raster point. So hopefully this makes sense. One thing that I do want to kind of point out here is this radius. What is this radius doing? Because I think I want to talk about radius or bandwidth for just a second. cannot write today. Radius or band, W-I-D, bandwidth, right? As a general rule, the higher the radius, the more influence faraway points have. Or put another way, right? The higher the radius, the more even the density will become. So sort of to put this in perspective, right? Let's just take a quick one-dimensional example. Right? If you have a short radius, right, your density is going to look like this. You're going to have a lot of high density in some areas and low density in others. If you increase the radius, you're going to be spreading that density out, which means it's going to look more like this. Right, you're going to have relatively low density spread out across a larger area versus versus a lower radius. Right, this is low radius. This is high radius. Right, so this is the x direction. This is the density. So this is one dimension, right? Because I can't draw it in 2 dimensions. Right. When you have a low radius, right, you're concentrating that density really close to the points you already have. If you use a really high density, right, or a really high radius, you're spreading that density out farther away from the points you already have. Hopefully that makes sense. Again, if you mess with this in a software package that gives you really good graphics, you'll quickly see that trend, right? That the higher you put the radius, the more that density sort of spreads out. The lower you set the radius, the more sort of concentrated it is around the points you already have. So the obvious question that comes out of this, give ourselves a little bit more room here. The obvious question is, what radius do I use? Right? If radius is clearly very important, right? Because if you pick the wrong one, you're going to spread your density out too far. If you pick the wrong one, or if you pick the wrong one and it's too small, you're going to have the density be far too concentrated. Right? How do you strike that balance? The way that I would approach this would be to think about the dispersion in the data you already have. And what I mean by that, and this is sort of the default that ArcGIS Pro uses, right, is you have 2 ways you can look at it. You can calculate, so if we have some points, right, we can calculate the geometric center of those points. So this is the average x and y. Let me make that clear. This is the average x, average y. Right? That's what it means to be the geometric center of all of these points. Right? Calculate the distance from this to all of them. Right? And then calculate the standard deviation. Right? So that would be the approach that I would use. Would be to calculate the standard deviation. But you want to go a little bit less than that. So typically a value of 0.9, and then you want to account for the number of points you have. So you want to multiply by n, and then negative 0.2. Now I know this equation seems kind of random, but this is the default that ArcGIS Pro uses because it strikes a good balance of relating, what already how is the data set already structured, as well as taking into account how many points you have. So this is a good default, right? The standard deviation in geometry times to make it slightly smaller and account for the number of points. Hopefully this makes sense. We're going to go through a sort of real example in the next video. So as always, again, if these specifics don't make sense, please rewatch the video and please reach out. Thank you.